All right, so who has an idea of what they would want for u to be?
X cubed plus x plus 6.
Okay, so let's let u equal to x cubed plus x plus 6. Now, sometimes it's a tendency to want to put this 4 with it, but very rarely will you put the exponent with it. There are some times when the exponent will come in, and another thing is, if you pick the wrong value for u, 9 times out of 10, it will show itself to you that, hey, you picked the wrong value for u. So there's nothing wrong with picking the wrong value for u, seeing that it is the wrong value and starting over with a different u. So don't be afraid to, don't look at a blank paper. In other words, I get this, I'm thinking, okay, u substitution, and another thing to look for with u substitution usually comes with a product, because think about when you take the derivative with a chain rule, your answer is usually a product. So if I see a product and I'm wanting to undo a product, typically u substitution is going to be the best route there. So what is du equal to?
3x squared plus 1.
And I'm going to put the dx on the end. Remember earlier I said du dx was equal to that, and then I cross multiplied and got the dx up there. You can skip that step and just go straight to that. So, yes, I did something wrong, didn't I? Because that doesn't work. So how about me changing this to 2x and this to 2x? Nothing like changing a problem midstream. So, thank you. Yeah, that was not going to work. All right, so what are we left with here? Well, I'm saying that u is equal to this value right here. So it's the antiderivative of u to the 4th, right?
Yep.
And then this is, the remaining portion here is my du. So it's u to the 4th du. All right, and what is the antiderivative of u to the 4th? Plus c. And u to the 5th is this x cubed plus 2x plus 6 to the 5th over 5 plus c. My college professor, I remember her telling me with the u substitution, she said she did not learn, when she learned how to do antiderivatives, she did not learn antiderivatives with u substitution. They just had to pick out, okay, this is looking like it's going to come from a chain rule, so she said that they didn't really do u substitution. They just had to determine that basically their step would go from here to here without the u substitution. So u substitution makes it something visible that you can walk through and see a little easier. So this is basically a concept that's really just come up in the last 40 years. All right, now we're going to get into one that is not going to be like set up in this form right here. So we're going to go with the cosine of x over the square root of 1 plus sine x. All right, now the next step I'm going to do is not necessary, but I think it'll help you see this a little bit better. I'm going to have the cosine of x, and then I'm going to write this in exponential form, which would be what? Very good. Now, so far, what has been in common with the problems we've looked at with u substitution, we've pulled our u from the value that had an exponent with it. Correct? So, out of my numerator and my denominator, which looks like it would be the best thing to do for u? Denominator. So I'm going to let u here equal to what? 1 plus sine of x. Okay. So based off of that, what would du equal to? What now? Not cosine squared. Just cosine of x, right? So it's going to be cosine of x plus a constant. Are we still good? No. We're not good because that's horrible. I'm getting to the answer too quick. Cosine x dx. All right. Now is there a question about it? All right. So, how do I rewrite this? Du over u to the 1/2 power. Or I could write it as 1 over u to the 1/2 power du. Does not matter which one you do. Both of these are saying the same thing. It's just whatever your preference is. All right, now there's a second thing happening here. Remember, we don't have a quotient rule with antiderivatives. So how do I handle the 1 over u to the 1/2 power? I'm going to make it u to the negative 1/2 power. So this becomes, either way I do it right here, this is going to be u to the negative 1/2 du. And now I've got it in x to the n form, correct? Okay. So, what do I do with this u to the negative 1/2? Say it louder.
U to the 1/2 over 1/2.
Very good. Remember, what's negative 1/2 plus 1? 1/2. So it becomes u to the 1/2 over 1/2 plus c. And if I divide anything by 1/2, it's the same thing as doing what? Multiplying by 2. So it's going to be 2u to the 1/2 plus c. And u is the same thing as what?
1 plus sine.
1 plus sine of x. So it's 2 times the square root of 1 plus sine x plus c. I always thought sine x would have been a good name for a nasal medicine. Congestion is bothering you, take sine x. Alright, that was lame. But it made me laugh. And in here, that's all that really matters. And there's no way to check these problems, is there? There definitely is. What do you think would be a good way to check it? Yeah, just take the derivative. If you ever think, hey, is this right or is this wrong? Well, go back through and check take the derivative. Okay. If I have 2 times 1 plus sine of x plus any constant, so. All right, and this is to the 1/2 power, right? Okay. So how do I take the derivative here? 2 times 1/2, which is 1. So it's 1 plus sine of x to the negative 1/2 power, right? And then what's the derivative of 1 plus sine of x? Cosine of x. And what's the derivative of a constant? 0. So I end up with the cosine of x over 1 plus the sine of x to the 1/2 power. Guess what I started off with? It's just crazy enough to work. Are y'all good? Okay. Now, sometimes we do have to do a little manipulation. That doesn't mean look off our neighbor's paper. Substitution does not mean substituting your work with someone else's. All right, so let's go with sine cubed x cosine x. Dx. Now again, I like writing it like this for the purposes of me working a problem. It just helps me see it better, but you definitely do not have to show that step. So, what do you think we want to do here? Yeah, u is equal to sine of x. So du would equal to, keep going, dx, yeah. And the reason the dx is important is because it's going to be in this problem here, so we need to make sure we remember it. And a lot of times when you look back at it, you'll be like, oh yeah, I should have put a dx right there. So, actually this is not one of the ones I have to manipulate. So this becomes u cubed du, right? Okay, and the antiderivative of u cubed is? So it's, that is my answer. All right, this is the one I'm going to have to manipulate on. Can I erase this? All right. All right, so we've got x squared times x cubed plus 7 to the 4th power. You good? Yes, that is a 7. Again, I've asked Santa Claus for a new handwriting for Christmas this year, so I'm going to see if he's going to come through and get me one. All right. That sounds like a philosophy question with bad grammar. So talk to me. All right, let's go with it. U equals x cubed plus 7. So du equals to with 3x squared dx, right? Now, what looks like it might present itself as a problem here.
Doesn't make substitute inherently to that.
It does, it doesn't. I don't have a 3x squared dx up here, do I? Any suggestion? What?
Couldn't you just do like u times 3 times du when you're running out? Like, since
What do we have an x squared dx in here, right? I've got an x squared dx right there, right?
you just like divide it by,
Let's divide by 3.
yeah.
Is that what you were saying?
I
Or
think
meaning?
so. I think
You
I was
think
getting
so?
there.
All right. So x squared dx is the same thing as du over 3. So my new problem here is u to the 4th times du over 3. Now, I'm going to show this extra step. I do not expect for you to show this step, but this could also be thought of as u to the 4th times 1/3 du. Do you follow what I did there? Okay. Now, u to the 4th is nice, du, but what do I do about this 1/3 in here?
Just put the 3 as a denominator to u to the 4th.
Say that again?
Like just shift it over, multiply by u to the 4th.
I'm gonna go ahead and just pull it out front entirely. You don't have to, but I'm going to. So I'm gonna make this 1/3 of u to the 4th du. Remember, we can do that with a constant. We can pull a constant out front. So this becomes 1/3 of, be careful, u to the 5th over 5 maybe?
Yeah.
Does that make sense? Why it's not u to the 4th over 4? Okay, remember, you've got u to the 4th right here, so you want to add 1 to it when you take the antiderivative. So this becomes 1/15 of, and what is u? X cubed plus 7 to the 5th power plus c.
Could you write it, u cubed plus 7 to the 5th over 15? Like where you have the 1/15th times.
Right here? What are you asking me now?
Can you, instead of having 1/15th times, could you just put it over?
Is that what you're asking?
Uh-huh.
What do you think?
I think yes.
You're correct. That is fine. All right. So, yes, you do not have to put the 1/15th out front. In fact, I'm going to go out on a limb and say if this was a multiple choice question, it would probably be written like that in the solution set. All righty. So, it's time for me to give you one on your own. So, we're going to go with